Worldwide. Aeros Corp is an American manufacturer of airships based in Montebello, California. It was founded in 1992 by the current CEO and chief engineer, Igor Pasternak, who came to America from Ukraine. The company's current products are non-rigids aimed at both the military and commercial markets, including transport, surveillance, broadcasting and advertising. Worldwide. Aeros Corp is also developing what it calls the Aeros craft, a rigid airship with a number of innovative features, the most important of which is a method of controlling the airship's static lift, which can be reduced by pumping helium from the internal gas bags and storing it under pressure. Conversely, lift can be increased by re-inflating the gas bags using the stored gas. The company has received $60 million from the U.S. Department of Defense to develop the concept, resulting in a prototype named Dragon Dream, which underwent systems tests and some tethered flights in late 2013. This prototype was subsequently damaged when part of the roof of the hangar at the former Marine Corps Air Station in Tucson, in which it was constructed, collapsed on 7 October 2013. History. Igor Pasternak founded a design bureau in Ukraine in 1981 at the Lviv Polytechnic University. The private company Eros was created in 1986 as a result of Soviet reforms and started producing moored balloons. It moved to the USA in 1992. In 2005, Eros was granted the largest contract under DARPA's Project Walrus Hula. Project Walrus was not renewed in 2010. However, the Pentagon continued to fund Eros through the Rapid Reaction Technology Office, contracting with them in 2010 to build a prototype that could demonstrate key technologies. This prototype became known as the Pelican. The Pentagon has provided $50 million in funding for the development of the Pelican prototype. Corporate timeline. 1981, Igor Pasternak establishes a volunteer airship design bureau at Lviv Polytechnic University in Ukraine. 1986, Eros becomes one of the first private aerospace and engineering companies permitted under Gorbachev's perestroika reforms. 1987, Eros launches a production line of tethered aerostats and begins worldwide deliveries. 1989, Eros begins the research and development on heavy lift airship concept. 1991, Eros begins its expansion and opens its first international office in Sofia, Bulgaria. 1994, Eros relocates to the United States to pursue its dream to advance lighter-than-air technologies. 1995, Eros develops its first airship, the Eros 50, that marks start of the Eros airship excellence. 1997, Eros develops the Eros 25M tethered aerostat system for the U.S. Department of Defense. 1999, Eros launches airship model Eros 40A. 2000, Eros develops the 40B Skydragon airship equipped with a fly-by-wire system, and receives an unrestricted type certification to fly worldwide over populated areas. 2001, Eros 40B is delivered to Germany to provide services in the land of Zeppelins. Eros 18M was produced for the Canadian market. 2003, Eros receives a contract award from the U.S. Department of Defense for the development of a high-altitude airship. 2004, Eros delivers the 1170 tethered aerostat for the U.S. military to ensure success in the War on Terror. For the first time, Eros creates a new type of rigid variable buoyancy air vehicle called the Aeros craft. 2005, the Pentagon's Defense Advanced Research Projects Agency contracts Eros to develop a buoyancy-assisted strategic airlifter. 2006, for the first time ever, Eros demonstrates a new technology that allows buoyant vehicles to operate without ballast. 2007, Eros develops a new 40D Skydragon airship that becomes a worldwide system of choice, and receives a FAA type certificate. 2008, the United States Federal Aviation Administration recognizes Aeros product quality and awards a production certificate. For the first time in aviation history, Aeros successfully demonstrates the ability to control buoyancy in flight. 2009, Aeros successfully demonstrates the rigid aerostructure that allows buoyancy-assisted air vehicles to have greater military utility. Aeros begins construction of the Aeros craft, designed to offer game-changing air cargo capabilities. 2010, Aeros develops a new advanced surveillance tethered aerostat system, in support of the Republic of Korea Armed Forces. Aeros puts its focus on the technology development for the wind energy industry to achieve 10 megawatts power output. 2011, Aeros continues integration of the Aeros craft, an air vehicle that will revolutionize global logistics. 2012, Aeros delivers on time and under budget on a $35 million contract with the DoD and DARPA, proving all of the technologies and capabilities of the Aeros craft. 2013, the Dragon Dream had its first float on January 3. The Pentagon declared the tests were a success. On July 4, the Dragon Dream rolled out of the hangar for the first time, and on September 11, the first flight of the Dragon Dream occurred. 2014, Aeros launches 40D Skydragon SN-22 into service following congressional christening ceremony, completes design freeze for ML-866 Aeros craft. Initiates production of new 40E Skydragon airship, develops and deploys a new tactical aerostat design, advances the company's IP position for the Aeros craft. 2015, Aeros receives patent from USPTO for revolutionary COSH buoyancy management system, launches the North American Defense Advanced Technology Solutions Division, readies launch of advanced 40E Skydragon airship, and continues production on the world's first cargo airship, the Aeros craft. Aeros craft. The Aeros craft is a heavy-lift, variable buoyancy cargo airship featuring an onboard buoyancy management system, rigid structure, vertical takeoff and landing performance, and operational abilities at low speed, in hover, and from unprepared surfaces. Aeros' unique and patented COSH technology breakthrough permits airships to efficiently address global cargo logistics applications for the first time. This new capability will dramatically decrease the time and cost for delivering large project and container cargo around the world, especially to austere areas with no pre-positioned infrastructure. Worldwide, Aeros Corp is also developing what it calls the Aeros craft, a rigid airship with a number of innovative features, the most important of which is a method of controlling the airship's static lift, which can be reduced by pumping helium from the internal gas bags and storing it under pressure. Conversely, lift can be increased by re-inflating the gas bags using the stored gas. This prototype was subsequently damaged when part of the roof of the hangar at the former Marine Corps Air Station in Tustin, in which it was constructed, collapsed on 7 October 2013. Project Pelican and Dragon Dream. Project Pelican was a U.S. government-funded project to build and test a half-scale prototype of the proposed full-size Aeros craft, using representative structure and avionics. Named Dragon Dream and having a length of 266 feet and design speed of 60 knots, it does not carry a payload. The company received $60 million from the U.S. Department of Defense to develop the concept, resulting in a prototype named Dragon Dream, which underwent systems tests and some tethered flights in late 2013. The flight of the Dragon Dream, with funding from the U.S. Department of Defense, the first floating took place on January 3, 2013 at Tustin, California, where it hovered indoors at a height of 12 feet for several minutes. The Pentagon has declared that the tests of the Pelican were a success, with the craft meeting its demonstration objectives. The Pelican was rolled out of its hangar on July 4, 2013. The company sued the Navy for $65 million in 2015 after the hangar structure fell on the aircraft. planned full-scale craft. The company is beginning production of two examples, an ML866 and an ML868 model. A model capable of lifting 500 tons, the ML86X, is also proposed. The ML866 model will be 555 feet in length, have a payload capacity of 66 tons, a top speed of 120 knots, a range of 3,100 nmi, and an altitude ceiling of 12,000 feet. The larger ML868 model will be 770 feet in length and carry 250 tons, with the same speed and altitude ceiling as the ML866. Aeros is currently seeking $3 billion to fund the construction of 24 Aeros craft vehicles, including the 250-ton capacity ML868 model. Capabilities: vertical takeoff and landing. Another way to understand the Aeros craft's VTOL capability is to compare the Aeros craft to a submarine. For example, when a submarine needs to dive into the water, it takes on water to make it heavier. When the submarine needs to surface, it releases that water to become lighter. Similarly, the Aeros craft can control its weight by releasing and taking on air, controlling the heaviness or lightness of the vehicle. One obstacle that conventional and hybrid airships face is their inability to control buoyancy without venting helium. Another operational challenge faced by airships and hybrid airships is the inability to control or adjust static lift during operations. Traditional airships' requirement for external ballast exchange in existing ground infrastructure has significantly limited their cargo utility. Once the cargo is offloaded, traditional helium-dependent airships become extremely light, and this static lift causes them to float away. To combat these forces, they require external ballast exchange, using rocks, ice, water, or lead bags, to keep the airship anchored to the ground. Because the Aeros craft is equipped with VTOL capability, it can deliver cargo directly from point of origin to point of need. Because of its COSH technology, its computer-controlled virtually automated directional thrust and station-keeping technology facilitates off- and on-loading stores while in hover. Oversized cargo bay. The cargo bay is located at the bottom of the aircraft cavity and is loaded by using a pulley system to load the cargo from the ground. The cargo bay of the largest Aeros craft is much larger than any bay container in any commercial freight aircraft carrier today. Design: the Aeros craft is a rigid airship, having an internal structure to maintain its shape. As such, it can reach otherwise difficult or inaccessible locations and can hover indefinitely at zero airspeed and with a full payload on board. The design incorporates cargo bays that are larger than any current air, truck or rail transport, while the payload capacity is significantly more than the current 16-ton maximum for helicopters. Propulsion is provided by conventional propellers, and in addition the Aeros craft design has 6 downward-pointing turbofan jet engines that assist in vertical takeoff and landing. These turbofans, together with the Aeros COSH buoyancy control system, make the Aeros craft capable of taking off and landing vertically without the need for a runway, a ground crew, or external ballast. Like any airship, the Aeros craft may be used to transport cargo to remote or difficult locations and to hover over uneven terrain, in both civil and military use. Its operational independence from runways, ground crews or other infrastructure makes it especially suited to military and emergency relief operations. The large cargo bays would allow outsized cargo such as wind turbines or large aerospace parts to be stored internally. The manufacturer also envisions the delivery of large amounts of commercial merchandise from a centralized location. Technology: control of static heaviness. Aeros has developed a technology to avoid the need for ballast, which they call control of static heaviness. The main gas bag is inflated with helium to create lift for takeoff. Then on landing, some of the gas is recompressed into a storage tank to partially deflate the gas bag and reduce lift. The COSH system also avoids the need to reballast when taking on or dropping off payload, and consequently also the associated ground crew. Worldwide, Aeros was awarded a patent of their control of static heaviness system internal buoyancy management system in May 2015. The HPE units contain and control the compressed helium and allow the overall helium volume envelope to be reduced or increased, enabling the air vehicle to become heavy or buoyant in a controlled manner. The compression of helium into the HPEs creates a negative pressure within the Eris craft aeroshell, permitting air expansion chambers to fill with readily available environmental ballast, which acts in concert with reduced helium static lift to make the aeroscraft heavier, when desired, to compensate for adjustments in payload. Proprietary information. Rigid structure, or generally, airships have a non-rigid structure, and these vehicles rely on the gases that fill them to retain their shape. The aeroscraft has a rigid structural design and is the only rigid structure or variable buoyancy air vehicle of its kind. Its rigid structure is made from ultralight aluminum and carbon fiber materials. It consists of transverse bulkheads which are connected to longitudinal members. It is reinforced with high-strength composite tensioned cables. This rigid structure provides an excellent range of hard points for mounting engines, canards, cockpit, propulsion systems, and other auxiliary systems both inside and outside of the hull. Landing system, replacing the more familiar landing gear found on airplanes. The aeroscraft is equipped with landing cushions that aid the vehicle's unique functionality. They aid landing on unimproved surfaces, even water, and perform like a hovercraft during taxi by pushing air through them. In addition, the landing cushions are equipped with very powerful gripping, suction capabilities that ensure the vehicle stays grounded and in place when not in flight. This reversible airflow helps hold the vehicle to the ground, even when the aeroscraft arrives at destination for cargo offloading, allowing it to operate in heavier wind conditions. Vectored thrust engines. The aeroscraft is equipped with vectored thrust engines that rotate and allow maneuverability, in addition to aiding helicopter-like vertical takeoff and landing capability. The vectored thrust propels the vehicle in forward flight and aids the vehicle with ground-based taxiing. Low-speed control. When in forward flight, the aeroscraft is controlled by the aerodynamic control surfaces. However, the low-speed control system aids the pilot in lower wind conditions such as during VTOL and hover. The LSC system acts as a rear thruster to propel the vehicle in forward flight, and permits the thrust to be redirected while in hover to help the vehicle maintain desired positioning and orientation. Fleet. Airships. NADATS. NADATS is a division of Worldwide Aeros Corp which serves operators with elevated early warning systems, tactical ISR solutions and custom, mission-specific equipment for actionable intelligence in hostile environments, for border and coast guard, for facility and event security, and for related missions. Elevated early warning systems. Skydragon airship surveillance system. The Skydragon is a series of airship that have been used anywhere from military, surveillance and commercial use. The first Skydragon 40A was completed in 1999. Following the 40A, the 40B was delivered to Germany in 1997. In 2007, Aeros Corp developed the 40D, recognized as the worldwide system of choice, which received a FAA type certification. The 40D was later delivered to Mexico in 2014. Aeros' contemporary 40 Skydragon airship has a useful payload greater than 1 ton, range exceeding 500 kilometers, 24-hour mission duration, and can observe up to 70,000 square kilometers at a time.